Okay, thanks everybody for attending the second uh, iteration of this uh, webinar. Um, Many thanks to Testmeter who have partnered with us on this. They are our leading provider of solar PV test products and solutions, experts in where to find the right solution, and they also offer try before you buy and hire options if a particular product mentioned today is not something that you're going to use on a regular basis. Please feel free to sort of talk to Testmeter, and those options are available. Okay, so we'll start off. We're looking at solar test tools and the installation and maintenance of our products. Okay, so just quick introduction to Fluke. We're 75 years old this year. We've got over 1,000 products just in the Fluke industrial itself, over 3,500 employees. We have sites in 39 countries, but work in many more, and we're active on things like blogs, webinars, etc. Okay, moving through. So this session we'll be looking at the best practices in installation, verification and maintenance of photovoltaic solar installations. As we said, we'll look at all of the type of products that you might be using with reference to this. And in our agenda, we'll be looking at solar energy trends, market segments, troubleshooting, solar installations, how to test the solar systems, and some notes on the future. Okay, so as we see here, solar energy works by capturing the sun's energy and turning it into electricity for your home or business, and comes in 3 flavors, all of which have roughly the same sort of technology: residential, large commercial and utility scale. But basically all of these things will work off the same type of principle with certain other considerations due to the size and potential issues. Okay, so just a quick look at the global energy sources. As we can see, back in 2019, and 2020, which as far as we can go globally, a lot of the power generation was hydro, and solar only accounted for about 11.4% of that generation. But obviously, that's going up quite considerably with both solar and wind. So we'll see that percentage go up in terms of usage. Just looking at the UK market, the solar capacity as of 2021, which is the most up-to-date figures that we can get, is around 14.6 gigawatts. Experts suggest that we'll be moving that up at 0.73 gigawatts per year, and currently there are almost 1 million homes with solar panel installations, which means that only 3.3% of all of the 29 million homes in the UK are generating electricity through solar panels. There are also currently just under 500 solar farms operating in the UK, which provide clean energy to the grid. Okay, so the market trend is increasingly going to 1,500 volts as opposed to traditional 1,000 volt systems. One thing that we should note is that these 1,000 volt systems aren't going to disappear. It's just a percentage of the actual market. So the market's going to increase. Traditional 1,000 volts are still going to be there. They are installed with a view for being there for a long time, but because of the things like increase in solar farms and commercial properties going up to the 1,500 volt systems, you will see that percentage going down. But there will still be a need to measure 1,000 volt systems. The reason is that solar panels have significantly improved their efficiency over recent years. Moving to 1,500 volts means more energy from fewer panels. And again, as we've said, the solar panel farms, which are 1,500 volts, are going to be generating considerably more wattage. So before we go into the presentation itself, we need to look at the category ratings in a solar installation. Long story short, the solar array part of the system is actually Cat 3. I'll go into what the categories mean in a minute, but we've got the standard photovoltaic panels testing procedure is IEC 61730-1. If anybody doesn't actually remember all of these IEC standards, I know I certainly don't, but I do know where to get them. With this session will be recorded. You'll see my details at the end, and if you need anything else, by all means, email me and we'll look at that. and it's all to do with over voltage categories. But put simply, the category rating involves looking at the peak value of a transient. So let's look at category 3. If we've got a 600 volt to 1000 volt Cat 3 system, the maximum peak value is 8000 volts. Whereas in the case of a Cat 2, it's 6,000 volts. So you can see that you need to use the correct equipment for the category area that you're operating in. Let's have a look at some of the situations that you might come across if you're looking to test and maintain solar panels. Residential and small commercial needs, you will still be looking at measuring multiple test points simultaneously. As we can see from this screen itself, there's going to be a lot of testing points, different appliances and points that you'll need to test, and you will, if you're doing this in any number, you'll be looking at testing hundreds of results, needing to report that to the customer, and often using a CMMS system dependent on how large your application is. When we move up to large commercial, there'll be more solar panels, and everything is basically upgraded. You're going to be measuring panel degradation. Again, thousands of results you'll need to report to the customer, and again, that's going to need to have some sort of organization. With utility, we've got even more issues scaled up. We can see here that the technical installer, for an instance, will be looking for a radiance meter, digital multimeter, clamp meter. There'll be more products that are potentially being used, and again, documenting this is even more important in a utility scale solar or photovoltaic, as we say. All of the photovoltaic systems, PV systems, can be tested against the test standard IEC 62446-1. This comes in several languages, but everything that we talk about today will be actually in accordance with this 62446-1. Okay, so IEC testing requirements basically says that when installing, commissioning, and executing maintenance on PV systems, technicians verify safety and performance as per the standards. It requires that the AC test circuits are tested first, and then the following 6 tests need to be performed, preferably within this order. So we're looking at continuity of equipment and grounding conductors, polarity of all DC test cables, open circuit voltage, short circuit current, test functionality of major system components, and test the insulation resistance of the DC circuit conductors. In addition, what we're going to be looking for is the IV curve tracing, which basically says, is or are our panels actually being used or performing in the way that we expect them to? So, firstly, we're going to be looking, and this graphic will change slightly as we move on. The first thing we need to do is safety testing at the AC side, and that will be tested to the test standard of 60364-6. That those tests will include, but are not completely restricted to, continuity of the protective conductors, insulation resistance, VOC and ISC test, blocking diode check, voltage AC and DC, and current AC and DC. And we've got one tester that will do all of that, and that's the Fluke Solar SMFT. But again, because of the fact that it is on the AC side, certainly in a residential property, you have got other products that you may already own that can do that. The next thing we need to do is start moving to the solar installation, the DC circuits, and the photovoltaics test standard for that is 62446-1. You're probably going to be very bored by the end of this with all of the IEC regulations that we're looking at, and this includes continuity of the conductors, insulation resistance test. We can use multifunction installation tester. We can use the Fluke SMFT series, or the solar tester, or we could use an insulation tester such as the Fluke 1503 and 1507. Moving on to functional testing, and we can see that the graphic has changed there. We're going to be needing to look for the polarity of the solar modules and strings, open circuit voltage of the generator solar voltage, string current, short circuit or operational of the generated solar current, and also look at the solar irradiance and solar module temperature. We'll be going into that slightly later on. To do that for the irradiance, do a Fluke IRR1 meter, and for the clamp meter, which theoretically should be the go-to for all but both maintenance and installers of solar, the solar clamp meter Fluke 939FC. We'll be going into that later on. So finally, we'll be looking at the functional testing, and that really is looking at the DC circuits. Are we getting the power that we are expecting? And we're going to be doing some IR inspection. Now, the starting cameras that we've specified for this is the TIS 55 plus or TIS 75 plus. This really is just a starting point. There are some very good features about these cameras that I'll go into later, but that's where you start. Because you're going to be quite close to the panel itself when you're doing things like the IV curve test, you can start at a lower end camera than you normally would. Okay, so let's go into the SMFT 1000. It will give you a full sequence of safety testing as per that category, or that standard. In the category 1, providing protective resistance, earth, voltage open circuit, short circuit current, and insulation resistance. Furthermore, with the category 2 testing, it will give you an IR curve, and along with that irradiance meter that we mentioned earlier, it'll give you irradiance at the solar panel itself, the temperature, and there's a thing you need to take into account when you measure the temperature of a solar panel, the tilt, and the bearing, which is basically where it is. So it's all about what is the happening at the solar panel itself, because when you install a solar panel, everything around it may change. For instance, trees may grow, large buildings may be put up, and the efficiency that you had years ago may not be the same. And because we put these things in hopefully for a long time, because they do have a somewhat long payoff, you will be looking for to make sure that that's providing an adequate amount of power. So along with this, we have our software, which is actually interchangeable, bidirectional in terms of data. So we can record data and export it to the report itself, but we can also take the database from the manufacturers and give an ideal test situation that can be downloaded to the tester itself, and we can look at whether the panel itself is performing correctly as per the manufacturer's guidelines. There are thousands of manufacturers and they're always increasing, but because TrueTest is updatable via the web, that information can also be taken and put it is constantly being updated on our TrueTest software. Just for reference, the standard IV curve is taken at 25 degrees at 1000 watt per meter of solar radiation. Obviously, that's not going to happen every day, but you can compensate for that. So let's move in. Where are we going to be using Fluke test tools? Well, we can see that we've got solar panels, combiner boxes, battery storage, inverter boxes, and in certain situations we may be near or involved in substation and transmission. So we've got tools that will be able to do all of that. For solar panels, when we troubleshoot these panels, we'll be checking the output of the entire system at the metering system or the inverter, trace out the individual branch wiring backward from the concentrator, check for polarity issues, and check overheated cells and connections. For troubleshooting the PV loads, we need to check the load switches, fuses, and breakers, check for broken wires and loose connections, and check the system's voltage and load connection. Now, we've got 3 products that can do this, but you can use others. We've got the clamp meter, the 393, we've got the solar irradiance meter, as we've mentioned, and again, a thermal imager starting off at the TIS 55 plus. When we're looking through a thermal imaging camera, It's quite interesting in that solar panels don't really want to get hot. What we really need them to do is transfer that energy and make it into electricity. If you see heat on a solar panel, that's usually not a good thing, or at least an area of concern. So you're looking at some examples here. We've got a defective cell from the front, the back. We've got a connection issue here, and also we've got high resistance connections in the cabling that comes out of the back. So all of this can be very quickly checked. Sometimes not from the back, obviously, because they're on roofs with a thermal imaging camera, but you do your best in the situation you come across. So the TIS range of cameras have one very unique feature in that they are both focusable and fixed focus, and you do that by basically turning the focusing wheel to a certain nodule and converting the camera from a focusing camera to a fixed camera. And what that allows you to do is focus at 1.5 meters, but also it will give you a good picture as you're scanning. You can also get very close to the product, 15 oh sorry, the target at 15 centimeters, and you can get a context of the visual infrared details by using our IR fusion technology. But also, if you actually find something wrong, you can use both notes in terms of text notes, voice notes, and photo notes, especially if you're not the one going to be doing the corrective action. You can highlight a problem, and then you can basically use IR photo notes to kind of guide whoever's going to repair the issue that you've found with additional photos. And you can also wirelessly sync the results into your Fluke Connect camera through your phone. So when we're measuring the performance of the panels using an irradiance meter, there's several things that we need to take into account. Obviously, we've got the irradiance and the temperature, and for that, we're going to be using the Fluke irradiance meter. But one thing that we will notice is that the bottom if anybody can see my mouse pointer, the bottom photo is not best practice. We're not looking to actually put the product on the panel itself. There are maybe situations where you have to, but if you do so, you need to be very careful because there's a risk of damaging the panel itself. Far better, and conveniently, this clamp that we're seeing in the top right-hand side will actually allow you to clamp to the solar panel without risk of damaging it, and will give you all of the same readings in terms of irradiance, tilt, etc. The temperature, people are always tempted to actually measure the front of the panel. Ideally, you're going to be looking to measure the temperature from the back. That will give you the best readings because of obviously this lovely thing called solar loading. Okay, so just going through that quickly. Again, this is the Fluke IRR1, and it will give you the 4 critical measurements when looking at panels, which is solar irradiance, temperature, orientation, and tilt and inclination. It can be used in direct sunlight because of the high quality display, and again, perfect for solar technicians. Now, when we're moving on to things like combiner boxes, some of the products that you might be looking at are, again, our trusty solar clamp meter, earth ground tester, and again, thermal imager. Wherever we have cables that are carrying current, a thermal imager is always going to be useful. So we're going to be measuring amperage and taking the calculations with the clamp meter. Checking earth situation, and again checking for heat sources. So a couple of years, well, about 18 months ago, this was the first Cat3 1500 volt rated DC clamp meter. As time has gone on, the competitors have realized that there is a market there, so there are others available. But the advantage of what Fluke are doing, you get the traditional Fluke build quality, safety inbuilt with the Cat3 1500 volt rating. It will give you all of the Pomona test leads. It's got a thin jaw for access to cables in crowded combiner boxes, standard IP rating of 54, and again, because it's FC, it will actually be, you'll actually be able to transmit any readings that you get, both to the to the tester itself and also to your mobile phone. Okay, so you may be involved in battery storage, and for that we've got several products. Again, thermal imaging, there may be heat, but you may be looking at a battery analyzer, and we've got some information on that, but also power quality as well. So starting off, the minimum that you're looking from Fluke is 1736 or 1738. So those are three of the products that you may be looking for. With the battery analyzer, you're looking for drop in capacity, increase in resistance, that type of thing. So we'll just quickly double click on the BT521. It will measure internal battery resistance, DC and AC voltage, current, ripple voltage, frequency, and temperature. Because you've got many cells that you're measuring, you can actually set this to an automatic sequence. So you're taking many measurements that again are, that you can export for further analysis. You can log automatically if you so desire, and it's fairly intuitive to use. It's not overly large, the unit itself. A lot of the cables and test probes that go with it will make the unit quite a large unit, but the unit itself is just basically the size of a large multimeter. It's just the ancillaries that go with it. So let's look at inverter boxes. Again, we're looking at clamp meters, thermal imagers, and power quality for this. Check and record the inverter's operating voltage and current level. If the inverter does not produce the right amount of power, check for blown fuse, trip breaker, and broken wire. And remember that something that we haven't necessarily put into this this presentation is that always use your eyes. And again, you'll see that when we're talking about high voltages, we always recommend that correct PPE is worn, because testing live is under the HSE working live as well. Okay, so one of the things that you may be looking at if you've got a solar system and things like EV chargers, if it's in a commercial situation, you may have soft start motors or controllers for motors. There may be a lot of things that are causing harmonics. If you need a full G55 compliant product, that's where we're going to the 1755. I'll go into it later, but you may be measuring harmonics, and the Fluke power quality can do that. So starting off with, as we can see, we've got 1736 and 38. We've got at a glance power quality. It's got a safety rating of 1000 Cat 3 again. And that's really your starting power quality analyzer if you are going to be using this on a regular basis. In addition to that, we've got our 1750 series. Excuse me, I had a bit of a mare there, remembering what it was. It comes 1753, 5 and 7, and anybody who's used to using the 435, which is our original power quality analyzer, believe it or not, that was around in one form or another actually at the turn of the century now. So it's been around for a long time, got replaced about 2 years ago. But if you need full G55 compliance, we've got this new product available for you. If we're looking at substation and transmission, we've also got things like, again, power quality and thermal imaging, but we also now bring in acoustic imaging, specifically the II910, which can look at overhead line isolators for potential discharge. With thermal, you can look for hotspots in bushing, surge protectors, and cooling systems. And again, you can measure power quality parameters and collate with them with events that may be causing disturbances in the power line. Just some of the examples on partial discharge. You can see here we've got substation insulator partial discharge, line insulator discharge, surge arrestor, and also in the panels themselves, you can actually check these metal clad switchgear, etc., without having to touch the panel itself. Okay. So just a quick note on the II910. It's got 100 kilohertz frequency range. You can spot partial discharge from 120 meters. 120 meters, just to give you an idea, is so far away that you know that it's somewhere in the distance. So we have found, and I have found 120 meter partial discharge, but you tend to have to get a little closer to it to actually start finding localizing it, but you can detect it from 120 meters. It's got a inbuilt PDQ mode, so partial discharge quantifier, which can track and analyze the severity of the partial discharge. We're only going into this particular product slightly sort of in surface level this today. So by all means, if you're interested in going further into this, please give myself an email or talk to Testmeter, and they'll be able to help you out with that. But this is just one of the products that may be useful for this application. And one thing that we can say about this is also that you can capture images, and again, that photo notes is something very good to be able to give whoever's you're reporting to a reference of where exactly the area of concern is. So we've flown through this presentation, so I think it went well. If anybody's got any questions, I'll answer them at the end. So just going through the list of products that we may be using, the clamp meter, the 393. If you're into to the solar industry, probably should be in your pocket at all times. Something that's really useful is the radiance meter, which can give you all of the many results all at once. Thermal imager is always good from a safety point of view, as is the power quality analyzer and acoustic imaging. And something that may be useful in these applications are battery analyzers, earth ground testers, insulation testers, and indeed our new Fluke SMFT, which is relatively only recently launched. So if anybody wants any further information on this, we've got three effectively application notes, and if you take a minute to scan these, or again, email me at the address after the presentation, I can send these through to you, and any questions and taking it further, by all means do so. We'll go. Just a note on the future. We've actually recently acquired Solmetric. So what that means to our users is that Fluke are in the solar industry for the long term. Solmetric at the moment have a specific IV curve tracer, which will, an IV curve tester, that is rated to Cat3 1500 volts. That's one thing that the SMFT doesn't have at the moment. It's Cat3 1000 volts. But as we start to acquire and produce products that will go into the lineup, we will be covering the entire market, obviously, as the solar market changes. But certainly the Solmetric is now under the Fluke banner. So one Testmeter can get hold of Solmetric. It's currently being run as a separate company, so we'll see how that works. But the Fluke banner will increase its level of products specific for this marketplace. So that's a little idea of what's happening in the future. So just going to take a quick look at the chat. Yes, slides will be shared, and I believe that this will also be recorded as well. So yeah, by all means, you're more than welcome to the slides. We'll be able to send that to you. And just to give you an idea, if you're in the UK, my colleague Mark Sherwood covers the north of the UK. I cover the south. That's all theoretical, but we do cross territories sometimes, and we're all part of the same team. And again, I'd like to thank Testmeter for helping us out today. And if there are any questions in terms of inquiries for purchase, please let us know. and contact them, and we'll be able to help and even work out online or even demos themselves. Oh, got another question. Is there a certificate for the webinar? No, unfortunately, because it's just a webinar and effectively there isn't a test at the end of it. We can't provide a certificate of attend, or if you really need one, we can provide a certificate of attendance if you need to talk to your bosses, and obviously people have taken their time out of the day, so there'll be a certificate of attendance, but it doesn't represent any qualification, let's put it that way. But please, if you need me, again, it's john.reynolds@fluke.com. I can give you a certificate of attendance, excuse me. So, thanks very much, and sorry for the late start. It's due to the European and UK time. Thanks, British summertime, etc. But yeah, if there's no other questions on that, thank you so much for taking the time out of your day, and I'll bring this webinar to a close. Thank you so much. Oh, hang on, couple more. Oh, attending? Yeah, absolutely. Just email me and I'll get you a certificate of attendance. I'm just going to quickly go through there. Yeah, chat. Okay, I think that's it. Everybody, thank you so much for taking the time. And yeah, if there's any questions, again, we're always here to help. Thank you.